Hey guys, good morning. Welcome to the Fundamentals of Aerospace Engineering lecture. So in this topic, we're going to see the basic aerodynamics. This is Professor Nehru, Department of Aerospace Engineering. So we'll start. What is aerodynamics? By the definition, aerodynamics is a study of how airflow around objects, particularly as it's related to the movement of an aircraft through the atmosphere. The main importance of to understand the aerodynamics is understanding aerodynamics is crucial for designing efficient aircraft or airplane and achieving optimal performance during flight condition. Let us take this aircraft and the top and bottom the airflow is moving. If the object is stable or controllable, only if the object is in the aerodynamic design. So the importance of aerodynamics is efficient flight, fuel economy, stability and control. In efficient flight, aerodynamics helps in achieving efficient flight by reducing drag and improving lift. In fuel economy, reduction drag means less fuel consumption, which is crucial for long distance flight. For stability and control, proper aerodynamic design ensures stability of aircraft and control of the aircraft in various flight conditions during takeoff, landing, flight share, and maneuvering cases. The basic terms to understand this aerodynamics is aerofoil, lift, drag. The aerofoil, the shape of the wing or blade that is designed to produce lift when airflow over it. The lift is the force that acting perpendicular to the direction of airflow and enables an aircraft to rise and stay in airborne. So drag is a resisting of motion through the air that opposes the aircraft forward motion. What is the drag force? Let us take this aerofoil, the top and bottom airflow is in different surface. This pressure distribution makes the aerofoil to produce a lift and producing a drag. Importance of aerofoil design in aerodynamics. The application of aerofoil design is crucial in various applications such as aircraft wings, helicopter rotor blade, wind turbine blades, and hydrofoils. And in safety aspects, the proper aerofoil design ensures safety and stable flight by controlling airflow over the aircraft surface. This is the cut section of the wing and it's called as airfoil. The straight line between leading edge and tailing edge we call it as a chord line, and the symmetric section split up we call it as the camber line, and the top surface your upper surface and lower surface of the aerofoil. This is the main principle behind this aerofoil is Bernoulli's principle. Bernoulli's principle states that an increasing in speed of a fluid or air in the case occurring simultaneously with decreasing in pressure. Application to the flight, the fastly moving air over the top of the wing creates low pressure, while slower moving air below the wing creates a high pressure. This resulting producing a lift over the airfoil. How wings produce the or generates the lift? Basically, the wing is a combination of aerofoils. The shape of the wing is mainly designed by aerofoil. The curved shape of the wing aerofoil is designed to create a pressure difference between upper and the lower surface, resulting in producing a lift, which is changing the angle of attack. Angle of attack is the angle between chord line and the direction of oncoming air. The greater angle of attack can increases lift up to a certain point before causing a stall region. Let us discuss about the types of drag. We have parasite drag, form drag, skin friction drag, interference drag, induced drag. In parasite drag, we have two things. This is form drag and skin friction drag, causing drag by the shape of the aircraft. The skin friction drag causes by friction between air and the surface. Interference drag causes by intersection of airflow streaming around the entire aircraft like wing fuselage and empennage. Induced drag causes by producing a lift. It occurs in wing generated by deflecting air downwards. Let us take control surfaces in aerodynamics. The aileron, elevator, rudder. We know the main objective of this three primary control surface to produce pitching, rolling, and yawing. The stall, when control surface is operated and the lift is produces, a stall occurs when the wing angle of attack is too higher, causing the airflow to separate from wing and the wing to lose the lift force. And the effect, the loss of lift, when can lead to loss of control and potentially results in the spinning. It cannot be corrected during flight. Coming to lift to drag ratio, lift to drag ratio is the amount of lift generated by the wing comparing the amount of drag is produced. This ratio is, it is the L by D ratio, or we call it as a CL by CD, or we call it as the amount of height and the distance it produced. The importance of the higher lift to drag ratio indicates a more efficient wing, resulting in better fuel economy and longer gliding distance. So coming to the aerodynamic effect of placing the wing tip vortices in the wing. Wing tip vortices are a circular pattern of rotating air that form at the wingtip of an aircraft as generated as lift. This wingtip vortices have a very effective, or it have it effect. Wingtip actually causes the induced drag and or the horizon following aircraft hazard to the aircraft, particularly during takeoff and the landing. So coming, we can use the produce high lift devices like flap and slots. The high lift devices such as flaps and slots are used to increase the lift produced by the wing at the low speed during takeoff and landing. Types is flap, either we can use flap for producing lift, high lift, or we can use the slot. Flap is increasing the wing area and the curvature, whereas slat is extended from the leading edge of the wing. Both are increasing the wing surface area. Coming to the supersonic aerodynamics, here we have to use aerodynamic in supersonic condition which deals the behavior of airflow around an object when the speed of object is greater than the speed of sound. Challenges, mainly the shock wave, normal shock, oblique shock, bow shock produces before the object which crosses the high drag and high heat of the aircraft structure. In conclusion, the aerodynamics is a crucial for a flight efficient and safety. Understanding the basic aerodynamic principles is a key of pilot and the aircraft designer or aircraft engineer. Continues in research and development in the aerodynamic lead to advancement in aviation technology. So these are the basic things we have understood of the basic of aerodynamics in subsonic and supersonic condition. We'll see the remaining part in the next class. Thank you.